Great. So this is the public meeting of Kubernetes SIG scaling, September 15th, 2016. And I think we were just about to discuss agenda items. So one item is that I think towards the end, David wanted to give a demo of the stat dump stuff we're working on, and then Tim had an item about he wanted to talk about just now, which was splitting performance tests separately from functional tests, perhaps would be the way to say it.
Well, the end-to-end test suite is basically like a lump of things that kind of has a roll-up of everything. And we did it for expedience in the past. But the question I wanted to raise was whether or not we wanted to have a separate set of test suite specifically geared towards these longer-term performance tests. Because right now, we only have a small subset of things, right? We haven't really added much since over the last couple of release cycles, but we would like to add more. And we don't necessarily think the existing end-to-end test suite is the place to add them because we don't want them executed on a per PR basis. It's kind of like how Node end-to-ends broke off their own thing. It's a similar question, I guess.
I think it's a great idea.
So, can we effectively do that without having tight synchronization with the test folks at Google? I just feel like there's it always seems like there's a bit of a limbo in terms of sort of how you make progress and get visibility into a lot of that stuff.
So my thoughts about it is that basically performance tests, we can run them on very small cluster, which actually doesn't make much sense, and we can run them on large cluster, which is way too expensive to run them on every single PR.
Yes.
So basically we have internally suits that are running performance tests. Obviously there are not many of them, and if we have more of them, it would be great. And they should be blocking merges soon. It's not yet done. It's blocked on some issues still, but it should be done in a month or so, I think.
Some of these things you don't necessarily need to start blocking on. If we just had, stuff running and, every, 4 hours, and we just saw the trend line so that we just know when the shit hits the fan and we can nail it.
So for example, QMark 500 is already part of, it's running every, whatever, hour or something like that. And it gives pretty good results, basically. And it's part of it's non-blocking, but it's on merge queue. You can look at the results from it in the merge queue or submit queue page. So
I think part of if we don't do it on every PR though, doing something such that when it does, go above some threshold, we actually start alerting people, I think would be useful also. I mean, otherwise it's too easy to ignore that stuff. I mean, the nice thing about going in every PR is that if stuff starts breaking, people notice because they can't get work done.
It's filing, MergeBot actually is filing issues.
Oh, does it file issues? Okay.
So as far as I know, I think we have a SIG testing, right? Would it be their responsibility to build and maintain those testing infrastructure and also the dashboard so that we can use?
They would probably create the general pieces to make sure the automation is there, but we would probably create some of those tests, right?
Right. That's what I mean. They create the SIG testing, create the infrastructure and all those dashboard, all those Jenkins job, and we just write a test so that we make sure the performance is great.
Yep.
Okay, but I don't really understand what's the goal.
Right now, they're kind of lumped together, and we want to add more tests, right? And the question is, does adding more tests to the existing end-to-end test suite make sense, or would we like it to live in its own entity?
What does it mean exactly? There's a separate test. They're running on separate clusters. The only thing they share is, I guess, end-to-end framework.
Yes, but we're kind of just lumping tests into a ball, I guess, is the question.
Also, you want to write as end-to-end load test suite, so basically run a number of performance tests in a single big cluster.
Yes.
Yeah, that we can just use feature performance tag for it or something, and that will just work.
Yeah, I know. But it's just a question of where it lives. So,
well, we can just add that's like end-to-end performance or something directory, and that the guest should do it, right?
yeah, that would do it. Why don't I open an issue and we can just banter there and then make that happen?
Yeah, basically, I think that all the infrastructure is there, well, except all the tooling we love to have, but no one actually has time to build them, like good dashboards and stuff. And like creating a separate directory for tests should be straightforward.
All right, sorry, I'm just taking notes. Okay, so it sounds like nobody's objecting here. It doesn't sound crazy. Figuring out exactly where this lives and how we integrate it into the current tooling is going to be booted to an issue. Sound right? Okay.
Yep.
And okay, Hung Chao is adding some stuff. Thanks. Let's see. So other issues that we want to talk about. So getting a demo of the stat stump stuff would be nice. I don't see Bob. I don't see David online. Do you?
I do. He's here.
Okay. Is he in the room with you?
Yeah, I can see him in person and on Zoom at the moment. So. Okay,
maybe I'm just blind. Okay. So yeah, so we can seg into getting a demo of what's going on there.
Great. Let's try that.
Well, I have to share my screen.
Yeah, you share your screen to talk here.
Okay. So this will be a relatively brief demo. You guys can see it.
Yeah.
All right. All right. So this is just an overview of the work that we've been implementing in Kraken to back up Prometheus data so that we can later analyze it using various tools. So I'm just going to do this locally on my laptop for convenience. You can see I have no Docker containers started. So the first thing I'm going to do is I'm going to The first thing I'm going to do is define my environment, just briefly. One of the things to note about defining your environment is it's really important with Prometheus that you capture the start and stop time of the run. The reason is if you try to query past or before the start time or past the end time and your window is too large, it will actually return no data. So, it's important to remember when you started. I'm going to create a directory to store my database. You can see that it is empty. And I'm just going to start up Prometheus database or Prometheus server. And I'm starting it with a basic scrape, which scrapes my local laptop. So let's proceed over here. The first thing we'll do is we'll look at the metrics endpoint. We can see these are all of the metrics that it's currently collecting. Okay. Now we're going to start Grafana so we can view those metrics. And this is one part that may or may not go quickly. So I've done this earlier so that, okay. So you can see it's up and it's collecting metrics as of a couple seconds ago. Great. So here I document how to configure the database. We don't need to do that because it was done earlier. So the next thing we want to do is actually capture the data. So first, we're going to stop Prometheus by just sending the SIG term to that container. Okay, it's not running anymore.
We can't see what you're typing on that bottom window there. Somehow it's getting cut off.
Um,
I think you shared,
That's better.
you shared your browser, not your
Interesting.
desktop.
I see. Okay, sorry about that.
If you just stop sharing and then share your desktop instead of the window, you might be okay.
I am sharing the desktop.
No, that's
I
weird.
think the desktop's
I
just,
think it was just cutting off the bottom somehow. It's otherwise it's fine.
Can
okay.
you see it?
Yeah.
All right, there you go.
All right, so yeah, just cutting off the side. So what we're going to do now is we're going to remove the Prometheus data store. So we verify it's not there. Oh, oops. It doesn't matter. I actually didn't back it up yet. So let's go ahead and get the stop time. Okay, and these are the two times we need to remember, start time and stop time. Okay, so now we're going to extract the database. And this actually may end up causing a problem because so we're going to create the directory for Prometheus. We're going to untar the previously tarred up database. That's not working. And it. Oh, sorry. We don't need that. So we're just going to take a previously backed up database, which actually is going to lead to problems because we don't have the time for those. But you can see, so here's a backed up database. Okay. So the next part is we query that database with our start and stop times, and we end up with a JSON record that contains values, which are a list of lists. Each one contains a timestamp and a value, and in this case, we're just querying process resident memory. Okay, so we save that in a file. Okay, and then we can open that file and process it using, very short Python notebooks. And so in this case, we're using pandas. We can basically just load that JSON file in one line, and then using Boca, we can plot it in a single line. In this case, we don't have a particularly interesting graph because we're only plotting resident memory over 1 hour. And over 1 hour, the average is linear. So, so that's an ad hoc way to be able to do this analysis. In the future, so there are basically 3 ways that we view this data being used. One is once the data is backed up to be able to view it using Grafana again. There are a couple of caveats you need to know about trying to view with Grafana on a backed up data store. One is that the time has to be specified properly, so you need to remember the time when you back it up. Another is that Grafana may not be aware of Prometheus restarting, so you may need to restart Grafana in order for it to recognize the broken connection. And other than that, you should be able to use Grafana to view those real-time dashboards that you view normally. If you want to do anything more complicated, we have what I just showed, which is a simple IPython notebook, graphing a single value. Since it's a data frame, you could add additional columns. And then finally, you could use something like an ELK stack or something else to do more sophisticated searching, which Prometheus does not allow. And then finally, if you want to see the code that actually implements what I attempted to demonstrate there, so I skipped one step. It's here. There's a pull request from Kraken, and it contains all of the steps that I had just did, only it uses kube control instead of Docker. And then finally, this dashboard is the dashboard we've shown in the past. This has been ported to Grafana, and this is the list. So we're right now backing up all metrics which Prometheus exposes, but this is sort of a canonical dashboard for measuring pod scaling, and that dashboard is available in the pull request for Kraken services here. We're going to check that into grafana.net. They have a dashboard repository. So you can either get that JSON from the pull request or see it show up on grafana.net. So that's all I had for today. Are there any questions?
This looks really interesting. I'm wondering, is there a way that we could package this stuff up so that you could throw it at any Kubernetes cluster and have it start doing its thing?
Yes, so that's the ultimate goal right now. I showed the pull request. Once those pull requests are merged, there's another pull request for our CI system. But once all of the pull requests on our side are merged into Kraken, then every time we run density testing, it will automatically upload Prometheus data as part of our test results. I think the hope is that we also upload that for federated testing as well. So it'll be part of the federated test results that we share. I think that incorporating it, so if you look at the code, it's relatively straightforward. I mean, there are only like 3 steps, right? Stop Prometheus, backup data store, restore Prometheus. So I don't know, Joe, how do you think we could promote?
Well, so what I'm thinking about is the experience inside of Google for collecting profile information of sort of what's happening on an individual process is really kind of nice, and you kind of see this leak out in terms of some of the pprof stuff that you see in individual Go binaries. And essentially what you can do is you can just, hit an endpoint and say collect data, and then you download a file, and then there's a whole bunch of tools for processing and mucking with that file after the fact. And I'm just wondering, could we like package this up as a single container or a pod definition where it's like, okay, if you run this pod in kube system, it's able to actually throw it at any Kubernetes cluster, and it's able to actually discover enough to start collecting interesting data. And then, at the end, you tell it where to throw that data, and it can be, a cloud storage bucket, or you can, have it go into some sort of like, terminated waiting for download state where it serves it up on an HTTP endpoint so you can download it, something like that, right? So, I mean, at the end of the day, we might be able to do this in a way such that people don't even know that they're using Prometheus to collect a lot of this data. Does that make sense?
Yeah, and I think that's possible. I think the only hurdle that I see is that we currently depend on having an external volume. So in our case, we're using EBS. But as long as we would have to use persistent volumes. If implemented that way, I think it'd be possible.
But even without a persistent volume, I mean, you could use it using an empty directory, and then have it so that you can, tell it to stop, and then have it tar everything up, and then just wait to serve that, so you can just hit it to download it, and then have it quit itself out, right?
Sure, we considered doing that. The problem that we ran into is that once the Prometheus container dies, since we run this as a resource controller, the pod is viewed as unhealthy and it's restarted.
I would view it. I mean, I would view it as maybe as a job, right? I mean, this is a run once type of thing. You could run it as a job where it'll run for a certain amount of time, or until you sort of poke it and say, "Hey, you're done now." Package things up so that I can get it, and do analysis later. Now we can take it offline. I'm just some ideas on sort of like, if you could package it up such that you could just throw it at a Kubernetes cluster, and it just, collects data over the next hour and then makes that available somehow. That'd be really kind of interesting, I think.
I agree, and I think the container is the right way to do that.
Is the reason for the munging because we're serving up Prometheus metrics in the Prometheus metrics format, so it does its own time series database versus JSON. If we were to serve metrics via JSON, which is totally inefficient but useful for data analysis, would that potentially be more helpful for the long-term analytics perspective?
So we're actually doing that. So right now, we store the Prometheus database, and the only reason for doing that is so that you can continue to use Grafana dashboards to view it in the future. But this IPython notebook that I showed, this is reading a JSON file, and this query here, what we do is we query for all metrics. We run a query for all metrics and save a file, a JSON file for each metric.
Tim, your question was about keeping that stuff in the middle somehow, right?
Yeah. I was taking the man out of the middle. So I was, instead of querying Prometheus to get the JSON data, just like what happens if Kubernetes itself was serving up JSON-based metrics that you could just scrape and store directly into something like Elasticsearch or whatnot. So that way you could do your analytics directly. Would that be helpful, I guess is the question.
I think it'd be helpful. The only thing I'd worry about is if we're duplicating effort of not just Prometheus, but Heapster. So part of the advantage of using something like Heapster or Prometheus is that you get metrics that perhaps are unrelated to Kubernetes, but still impact the performance of the system.
Yeah, we have this weird, at a system-wide level, like there's this whole meeting that's after this meeting, which is about this stuff. We have this whole weird many metrics problem. It's like MacGyver, actually, if you combine all the ways we're collecting data across the cluster. So I almost want to attend the next one just to see how that one's shaping up right now.
Yeah, I'll be there. I agree. I think there is some confusion in terms of the one true way to get Kubernetes metrics.
Well, very cool. I love that, it's something that we can squirrel away and save and analyze later. And, I can see tools around sort of comparing and trying to figure out why is this one slower than that one, that type of thing, which is going to be critical.
Yeah, and just a technical note I put into chat, you're probably seeing no data because the step depends on the range and you can override the step.
Right.
Oh, you mean if you don't have the start end times, Brennan?
Right.
Right, that's the reason it's important to keep track of those. And so we keep a file with the start and end times in the directory that contains all the JSON and the binary data.
Right, just saying you can be a little fuzzy and adjust the step higher resolution.
Right.
Well, very cool.
Great. Thank you.
So we have about 5 minutes left here. Let's see. So, Bob, I know that you are going to be disappearing for a couple of weeks into stuff in Korea, right?
That is correct.
And so I'll be, I'll still be around. I may be a few minutes late though, so if I am, you guys can feel free to start without me. I have to drop the kiddo off and I have to run back home after doing that. So it's a close thing. If the bus is late, I may be late. But Tim, you've been a constant here, so I'll empower you to get things started if I'm not around.
Okay, I'll have to dig up the ACLs to push the magic buttons.
Yeah, it's a note on Zoom is that if you log in from the web and then launch Zoom from the web, it sort of like forwards your login information to the account to the installed app, right? So you can be like logged in on the app using one account, but then you can be logged in on the web using a different account. And when you launch a meeting from the web, it's the web one that wins. It's very confusing. Does that make sense at all?
It does. Tim, I can resend you those credentials if you can't find them. Just let me know.
Sure.
Any other notes? All right. Well, thank you, everybody. See a bunch of you at 10.
Great. See you.